Hi guys, welcome to the lecture number 11th for our NLP playlist. So guys, today we'll be talking about Word2Vec and I actually know how much depth I need to go in there and how much depth I don't need to go there. I'm making sure that we quickly start with LLMs and also we focus a lot on neural networks. So obviously I think till now I haven't discussed much about neural networks. So that's there, but I know but still we would try to get the essence of this algorithm and how does it work. So guys, first of all, why this lecture? First of all, let's just start that words have meaning. I have been stating this in my NLP course that words have meaning, and the only question that we as NLP researchers or NLP developers are trying to answer is the meaning enough to model the world. The thing is text enough? That's the area of debate. Let's assume it is. The next point that we need to know is that words needs to be converted into vectors so that we can apply any mathematical operation on top of that and we can, let's say, create any model. So the first thing that's there is that Word2Vec was released. This paper was released in 2013. It was released by Google. What is essentially the idea? The essential idea is that if we leverage this algorithm, we can convert words into vectors which have semantic meaning. So the question is, why do we want the vectors to have semantic meaning? See guys, if we'll use any methods that is based on frequency based, right? We saw term frequency, inverse document frequency, but guys, as I said, no one uses it, and now we want the idea that we have to get to an understanding that words can be represented as vectors, and the essential part of vectors is that similar vectors will have similar meaning. I showed you, right, in last class how do we compute similarity between two vectors. So let's say I have two vectors A and B and I wish to compute the similarity between them. So I can just compute the similarity with the help of basic cos theta. Okay, this is the formula, and essentially as you know that cos theta has this range, so the value that is more closer to 1 would mean the vectors are similar. Okay, so now the main thing is what happens in Word2Vec is how it was trained is, so there are two variants of it. One is skipgram and another one is SIBO. So we'll stick to skipgram for this lecture. So what happens under this is that, let's say you have a sentence, the cat sat on the mat. Basic sentence. Now Word2Vec essentially comes up with an idea that similar words have similar meanings. I think I've said this many times, but yeah, just iterating meaning. So the thing is that the cat sat on the mat. So you would have to train a neural network that would predict. What would it predict? It would predict cat, and what would be the input, or on what basis it would predict? Sorry guys. It would predict on sat on the and mat. So based on this input, it would predict cat. Now the thing is, we have seen, right, gradient descent and everything. That all only happens inside a neural network as well. I know I haven't discussed neural network, but that's okay for the time being. The main thing is that we need to train a neural network such that it is able to predict cat, and thus using this input. So usually guys, neural network has three layers: input, hidden, and output. So the main essence is that in the input layer only you would have this thing. In the hidden layer you will have word vectors. Okay, this would be learned, and here you will have the output as cat, and hence therefore guys, what happens is that you have a loss function. Initially it starts with random guesses, then you use this equation: w new is equal to w old minus eta cost function, right, with the respect to w old. You take the partial derivative of the loss function with respect to weights, and then you try to find out ideal value of these word vectors such that it can predict cat based on the input given. So guys, in simple terms, that's it. Okay, that's all you need to know. That Word2Vec is a neural network based methods. We have vectors, and guys, this is very simple to implement in Python. Okay, only 2-3 lines of code is there, so don't worry. You have Word2Vec. It is a neural network. It's not a Word2Vec is essentially the algorithm. The brain of it is a neural network, and it helps you get vectors, and the words are represented as vectors. Similar words would have similar vector. That means the cosine similarity would be pretty much same. And using these vectors, once you have these vectors which have captured the meaning of the words, you can build on and train any algorithm. Okay, let me give you some idea on a philosophical level. So see guys, when you say to chat GPT, let me just come up with a good example. So let's say you say, hey, isn't it funny how dumb you are? So let's just try to understand this sentence. Let me rewrite it. Isn't it funny how dumb you are? So guys, tell me, how do you think chat GPT is able to understand this sentence? It's because it has captured somewhere, right? I don't know where, but somewhere it has captured the meaning of these words. That what does funny means, what does dumb means, how is this in a sarcastic tone, why it is able to capture it. Because guys, somewhere down the line it has understood the real meaning of words. Okay, so that's how usually once you have vectors you can really understand their meaning. Okay, like a vectors, let's say there is a word say king, so king has usual, let's say a vector of 0 0.3, 0.9 and 0.9, and say this is of 300. So see guys, there are 300 dimensions. Okay, there are 300 dimensions in which you have written this word. All this is done with the help of neural network. Slowly you will understand, but you're able to see that how words get converted into vectors, and how those vectors can be later on used to perform any analytics, any advanced analytics, specifically training a network for further workloads, right? Let's say the task is essentially next word prediction, right? That's the problem that the world is capturing on. That's next word prediction. Okay, so just spare a thought and try to see that how is next word prediction able to, let me write some note, because guys, these type of things are important, not for your interview and all. I don't think the interview himself would understand all this stuff, but still it's important for you to appreciate these things, because guys, the world will change. Okay, the world will change. The thing is, next word prediction, right, it's a simple thing only. the same way, right? Here, like I explained you Word2Vec, I told you that based on this input I need to predict cat. Next word prediction, learning. So guys, let's say I give you a riddle. How do you think ChatGPT cracks a riddle? ChatGPT is able to crack a riddle, guys, because it has captured the meaning of world, what to whatever extent it has, right? It's just not a simple next word statistical based model, guys. That's the part that you need to understand. How can it solve a riddle, guys? How can it understand these things? Isn't it funny how dumb you are? Even if you'll write this U as this and R like this, like we chat, it is still able to understand, guys, because it has whatever understanding of the world it has. So slowly we'll also reach there. I know some of these things might be little overwhelming, but guys, stay with me. I understand what I'm designing, and this would be the best design NLP course that's out on YouTube, I promise that. So enjoy, guys, have a great day, and please subscribe to my YouTube channel.